I'm here at the Crow Science Building at the Hockaday School looking at Foucault's pendulum. When standing here, it looks like the pendulum is swinging around the pit, when in reality it's swinging in the same place. This is due to the Earth's rotation under the pendulum, which creates this illusion. How do we think the pendulum moves around the Earth's rotation? Maybe think about it at the North Pole, the South Pole, the equator. I'll give you a second to think about that. At the North Pole, it moves clockwise. At the South Pole, counterclockwise. At the equator, no movement at all. Therefore, we can conclude that as you get closer to the equator, the rate of oscillation slows down. How many times do you think it's knocked over per hour? Well, let's see. If we estimate, there's 4/4 of the whole circle. There's about, we'll say, 45 per section. Therefore, there's about 180 tiles in the whole circle. So if there's 180 tiles in 24 hours, approximately 7.5 are knocked over an hour. If you think about this in degrees, there's 360 degrees in the circle. In 24 hours, that's about 15 degrees of rotation per hour. So where else can we find pendulums in the world? Swings, on a playground, clocks.
Look, you can find a pendulum anywhere. Here I am on a swing on a playground. The pendulum swings according to the Earth's gravity. The period is how long it takes for the pendulum to get back to its original point, like that. The longer the string on the pendulum, the longer the period. The shorter the length of the pendulum, the shorter the period.